it's Miss Ash here, and today we are going to do some science experiments. And I had initially planned on us doing one that required some solar power, but unfortunately it's been quite rainy today, and I waited a little bit just to see if the weather would improve, and although we do have some blue skies, it's just not quite sunny enough for our initial experiment. So we are going to attempt some new versions on some oldies but goodies, and try some of our favorite ones that we've done together in the past. So I hope you're looking forward to this. I'm so excited, and let's begin. Okay, so for our first experiment, we are going to do a normal volcano. So we are going to need a container, and I just have an empty water bottle container. We're going to need some baking soda and some vinegar. Okay. So the first thing we're going to do is put our baking soda in our bottle. And the smaller the hole on your bottle, making a mess, the bigger the eruption should be, because there's not as much room for the volcano to expand. Now you could do this by burying your bottle in the ground or actually making a volcano body, but for today I'm just going to use my bottle and make a little bit of a mess here. So if you guys are doing this at home and you've never made a volcano before, you either want to use quite a big tray underneath, or you probably should do this outside. So we are on my front porch, and we're actually going to take this down onto the driveway. Okay. So we're going to put our powder here, and you guys can guesstimate how much powder you use. When you look at the experiment online, sometimes it tells you to do exact measurements, but I found as long as you have a fair amount of baking soda, you can just pour the vinegar in, and you can see it's already reacting. And here we go. So you guys can see it didn't have that big of a reaction, but again, it's because we didn't use a ton of baking soda and we only used a little bit of vinegar. But that was our first experiment, and a fun way to do a take on this that we have done at school before is to do it with Diet Coke and Mentos, and compare and contrast the Diet Coke to the Mentos experiment. So, unfortunately, I didn't have any Diet Coke or Mentos at my house, and I was trying to do all experiments with everyday things that you might have at your home. But if you have those, that's a great way to start. So, for our first experiment, we tried it with a small water bottle with a quite small opening. The next thing we're going to try is in an open cup. Now, I have quite a little cup, but you could do this with a bigger, like solo cup, or you could do it with a larger open mouth bottle. If it's up to you. But we're going to see what happens with the bigger opening to see if we get a bigger or smaller eruption. And what do you guys think? Do you think it's going to be bigger or smaller? I think it's actually going to be a smaller eruption. That's what I predicted with the bottle in the first place, which is why I chose the small one to begin. But let's see what happens with this experiment. Okay, so I put our cup right over here, and we're going to put a little bit of baking soda in. And I put in just enough to about one finger's deep baking soda in it. And I'm going to put a little bit of food coloring in this one just for fun. And I'm going to pick blue today because I was wishing it was blue outside. All right, are you ready? We're going to pour a little bit of the vinegar in. And did you decide if it was going to be bigger or smaller? Okay, I'm thinking bigger. I'm thinking smaller. What do you think? Ooh. That's pretty. So when we look at this, you can see the blue made a smaller ring on the driveway. But I think the foam at the top was a little bit bigger. So I think the foam was able to expand more or spread out more. So it was bigger up here, but it actually only had a smaller lava pool. What do you guys think? Did you guys think the same thing? If you try this at home, let me know if you have the same results. All right, we're going to try one more volcano-based activity. Okay, guys, so we did for our first one this water bottle with the small opening. We did a cup with a big opening, and now we are going to try the same experiment in a Ziploc bag. So what do you guys think? Is a Ziploc bag gonna help it or is it gonna hurt it? Do you think it's still gonna erupt? If it erupts, what do you think is gonna happen to the bag? Let's find out. Okay, so the first thing we're gonna do is open our Ziploc, get it nice and big. Okay. And I only had snack side baggies, but you could do this with a gallon size or a sandwich size baggie. Either way, whatever works for you. So what we're going to do next after we've opened up our baggie is we are going to pour a little bit of vinegar inside. So I poured about 2 fingers worth of vinegar into our snack baggie. And I think for this experiment, just so we can see the difference on the ground, we are going to try it with red food coloring. So we're going to put a couple drops of red in here. That was more than a few drops. You don't need that many. But we're going to try that. And then we are going to put a little bit of vinegar in here as well. Okay. So now you can see we have about 3 fingers worth of our water and vinegar mixture in here. So then I have a piece of paper towel that I'm going to fold up so it's a little bit smaller than the baggie that we're going to use. And we want to make sure we fold the edge on each side. And then we are going to put a little bit of baking soda in the center. Okay, now we're going to fold this all up. You want to try and keep all the baking soda in the center. So if you get some on the edges, give it a little brush off to the middle because we want to make sure that none of the baking soda mixes before we get it into the Ziploc with the Ziploc closed. So we're going to have to do this very carefully. Okay, so now I folded it into this nice little package, and I'm going to start closing the Ziploc a little bit, just because I don't think I'll be able to close it quick enough. Okay, and we're just going to dump this in here and go as fast as we can, and let's see what happens. Can you guys see it fizzing? Okay, so as it expands, look at the bag get bigger and bigger. Ooh, that scared me. Did it scare you? Our bag popped, and if we get a little closer, you can see all the bubbles happening inside the bag. Pretty cool. So this lets us see the experiment up close. And now that I moved it, you can see that when the bag popped, it actually put a hole right in the side, and it puts the reaction outside the bag. So as long as it's staying contained, the baking soda and the vinegar are working together to make all of these fizzy bubbles, which is the same thing that caused it to erupt in our other containers. But in this case, because it was in a Ziploc, it made the bag puff up and then explode. explode. So do you guys want to try that one more time, just so we can see this a little bit closer? I think that'd be fun. Alright guys, so I have already set up this experiment, and you can see I picked yellow today. It's not the best looking color, but I just wanted to be able to see a little difference on the cement this time. So we have our yellow vinegar, or our yellow dye, mixed with the vinegar and the water. And I'm going to put the baking soda back on our piece of paper towel again. And fold it up. So I have our little package right here, all folded up nice and neat, and you can see that the edges are folded closed, and all the baking soda is wrapped inside like that, just to make this a little easier for us. And last time I didn't get the seal on the bag quite good enough, so this time I'm going to make sure I do a really good job of that. I'm going to tuck this in. You can see it's already starting to mix. I got the seal nice and tight. We are going to get close. So you guys can see this bag is getting quite puffy. It's expanding and getting wider and wider. Get you from the sides, you can see. So it is quite wide, and let's see if we can see it pop. This one's not very fizzy, so I don't know if it's going to do that. Let's see. I don't see any bubbles. Do you guys see any bubbles? If there's no bubbles, do you think that this is going to erupt or explode? I don't think so. I think the bubbles are an important part of this experiment, and it's what helps us see the reaction between the vinegar and the baking soda. So I'm going to give it a poke and see what happens. Nothing happened. So I'm going to make you guys a little bit zoomed out. Okay, so you guys can see this bag is quite wide. It's quite, oh, there we go. There's the reaction. And you guys can see it expanding and getting bigger and bigger. And look, the bag is starting to stand up. Look at that foam on top. I don't know if you guys heard this, but I heard a little hiss. But it still looks like it's sealed pretty well. Look at how wide this bag is, guys. Oh, here we go. And it scared me again. Look at how big this got. So this is quite puffed up, and that is from all the gas that develops when the baking soda mixes with the vinegar. It causes a chemical reaction, and that mixture makes a lot of gas, and it produces the bubbles that you guys see right in here. We'll get a little closer. So it produces all the bubbles that you see in here, and it makes this puff up quite large. Like, this is huge, guys. Okay. So it gets quite big, and that is our chemical reaction. So that's our last volcano experiment. So for our next experiment, Miss Carla is going to show us how to make a lava lamp. And I don't know if you guys know what a lava lamp is. They used to be really popular. You should ask your moms and dads about them. See if they had any when they were kids growing up. They're super cool. So I'll insert a video right here of what a real lava lamp looks like, and then Miss Carla will show us how to make a lava lamp at home. Lava lamp. 3/4 cup oil. 1/3 cup water. 1 Alka-Seltzer. And food coloring to your liking. Homemade lava lamp. And watch it go. our next experiment, we are going to try and get water from this pie tin into this old cider jar. Now, the rules of this experiment are we cannot scoop the water, we cannot pour the water from the tin into the jar. So we have to try and figure out what we're going to use to get this water out of this tin. So we can't scoop it, and it doesn't work anyways. There's no water in here, so that doesn't work. Well, that didn't work. And we can't scoop it and put it in, and we can't transfer it. So we are going to try an experiment using this old birthday candle. We'll see if this works. And this lid to a plastic bottle. So we'll see what happens. First thing we're going to do, we are going to melt the bottom of this and use it to stick to our lid. Now, if you aren't comfortable melting the lighter, we could use hot glue or any type of sticky surface, but you want to make sure that it's stuck to it tight. So we're going to do that. Okay, so I have my handy little lighter right here, and I am going to get the bottom of this candle nice and melty. You want to be really careful so you don't burn yourself or burn your surfaces. Okay, that looks pretty good. And when we're done, we're going to set it in. And you can see it's not quite floating, but it is a little bit wobbly, and that's important. And you want to make sure when you're looking at this, the water level is not over the surface of the lid. If it spills into the lid, you have too much water in, and this won't work. So we are going to light our candle. Okay. We're going to let it get a little hot, get a little melty on top. And then we are going to very carefully set our jar over the top. And I don't know if you guys can see this. Let me get you a little closer. You guys can see our candle is starting to flicker. And if you look really close, I'm going to zoom us in a little bit. You can see that the water level has risen up into our jar. Do you guys see that? So now the water is above. Guys, I'm not good with camera, sorry. So our water level rose from the just above right here, so you can see it's above the curve of the jar. Now our candle's floating. So we're going to try this one more time where I get you up close so we can see it all the way happening. Okay guys, so I got our candle relit, and I'm trying to zoom in just so that way this way we can get an up close version of the experiment. So our candle's burning pretty steady, and I'm just going to very carefully set this over the top, and you can see the water is already rising. So our candle just went out, and now it's floating, and look at how high the water is moving and how quickly. And the reason this works is because as the candle burns up oxygen, it creates space, and the changes in the gas causes the water to rise up, and it then extinguishes the candle, but in that process it makes it possible for the water to be sucked up into the cider. If you guys actually know what the scientific name for this process is, please let me know. I know it's cool, but I don't actually know what this process is called or the exact chemical change that makes this possible. So if you know, please help me out. So we are just going to pop this off, and you guys can see it's pretty stuck to the bottom. And there we go. So now it's all finished. Okay guys, for our next experiment, we are going to try and make plastic or stone or I'm not really sure what. I read an article online, and it said that if you mix milk and vinegar, it will make a plastic-like substance. And I don't know about you, but that doesn't seem quite right to me. So I figured we would try it. Okay, so for this experiment, we need a strainer, a measuring cup, some distilled vinegar. White vinegar works especially well if you have that at home, and a container of milk. And we also need a measuring spoon, and we are looking for a single table today. So the first thing we're going to do is we're going to put the strainer in our sink right here. Oh, and you guys also need some paper towel. So we are going to place the paper towel in the strainer like this, and it is going to help us work for the later part of our project. We need a fine mesh strainer, and I don't have one, but if you have a fine mesh baking strainer, that will work for this process too. So the next thing we're going to do is take our measuring cup, and we need 1 cup of milk. So on my measuring cup, it is nice and handy because it says 1 cup on it. Right here, it's also equal to 8 ounces. So we need to measure it to 1 cup. Now you guys can also use your baking measuring cups. Either way, it doesn't really matter. But we're gonna pour this in. And when we are measuring liquids, guys, remember, you need to take the measurement from eye level, because if you look from above, sometimes the liquid gets kind of like concave, or it dips down, and you can't see the measurement really well. So you can see right here, now that we're eye level, there's actually a little bit of gap here. We're gonna try and get it right on the money. I don't know if we can though. Let's see. All right, looks pretty good to me. So we are gonna put our milk in the microwave right now. Okay. Oh, sorry, here's my angry lady who cleans my microwave for me. Okay, so we're gonna put the milk in our microwave for, let's do it for 2 minutes. You don't wanna do more than 2 minutes. 1 to 2 minutes is ample time. Okay, guys, so I needed about 1 minute and 30 seconds for this, and when I took it out of the microwave, it was pretty steadily bubbling, so it had a nice good boil on it. So that's how I knew it was ready. The smell of the milk also started to change, and we don't want to burn the milk. That's an important part of this. So once you see that steady bubble, we're good to go. So we are going to take our measuring spoon, and we want 4 teaspoons of vinegar to start with. And when you mix vinegar to milk, there's going to be a chemical change. So what do you guys think is going to happen? You can already see it start right here. I don't know if I can get you guys close enough to see that. Oh, there we go. So you guys can see that our milk is already starting to separate. You guys can see it kind of is starting like egg whites, where there's the whites pull away from the yolk. Our milk is starting to do the same thing. So we have 2 plus a little some. 3 and 4. So let's see. Now this is pretty separated, but it doesn't look like it's separated all the way down in our milk. Let's see if we can lift it. So you guys see the bottom, ooh, I'm spilling. The bottom part of the milk still looks okay. So we're just gonna put in, I think we'll try 2 more just to make sure it's nice and separated. We wanna do this until the milk is mostly in between the curds and the clear liquid, because we are going to pour this. Okay, I think that might be, yeah, so that looks pretty good. So when you scoop it with your measuring cup, you can see it's pretty separated at this point. Okay, guys, so we have the separated milk with the curds mixed with the clear liquid, and we are going to pour it into our strainer. Okay, and so this is why we have a paper towel in here, and it is going to be a little bit warm, so you guys want to make sure you're being quite careful as you do this. And you can just gather the edges of the paper towel and kind of give it a jiggle and let some of that liquid come out of the paper towel. And another way to do it is also to kind of twist it and press. When you're doing this, you want to be careful not just of it being hot, but you also don't want to bake or break the paper towel as you're doing this. And you want to try and get as much of that clear liquid out as possible, so you're left only with the curds. So this looks good, so let's open it up and see what we find. Okay guys, so I am going to use the same tray that we used from our earlier experiment, and I am going to open up our paper towel and dump the curds. So this is what's left from our experiment, and it's kind of a stretchy substance. It feels kind of like cheese, but not quite. It's like if cheese and glue got mixed together. And so I was reading online that this is something that we can eat. So let's try it and see how this tastes. It tastes kind of like really vinegary or really sour mozzarella cheese to me. So if you guys tried it, let me know what you think. I was not the biggest of fans. I probably wouldn't eat this again, but apparently you can. So we're going to press our mixture all together to make a flat piece, and we're going to use cookie cutters to try and cut out some shapes out of this. Okay, so we got a fish, and we have our heart. And we're going to use our cookie cutters to create shapes, so when this dries out, it will give us our plastic or our rock shapes or our different, it'll just give us different things to compare to. And then I'm going to leave the extra pieces here just so we can kind of see how these turn out, if they stay soft and squishy or if they harden up like plastic. So what do you guys think is going to happen? Are these going to stay soft? Are they going to get hard? Are they going to stay stretchy? Because right now they pull apart pretty easy, but it's kind of like really dry slime. That's how it feels when you touch it. So what do you guys think is going to happen with this? Let me know. Okay guys, so I did a little more reading on this experiment, and what's left over is actually called acid casein, and it's the proteins from milk, and it is apparently not water soluble. So I thought that would be something interesting for us to test. So I am going to put a little bit of water in this mason jar that I have, and we're going to take some of these pieces that, leave that one there. We're going to take some of these pieces and sprinkle them in our water and see what happens. Nothing. They just kind of break up and put really gross floaties in our water. So, with this experiment, these take about 2 days to dry. So I'm going to let them sit right here on my kitchen counter for 2 days. And on Monday, I'll post in the comments what these look like. But when this is finished, this actually dries out. These pieces dry out and make an organic plastic. And when we think about plastic, we normally think about things that are not organic. So, Miss Ash, what does organic mean? Organic means something that is made in nature, that comes from the world around us. So it's something that we can make from things outside. It grows on its own. It's not something that's man-made. And plastic itself is something that is man-made. It's something that we use by heating up little pellets, and the pellets are made up of different materials. It's not something that we can go outside and get from our natural environment. Unfortunately, because of pollution, it's everywhere, but it does not grow in nature. So normally plastic is not organic, or it is man-made. And so we are going to use this acid casein to create organic plastic. And I think that'll be super cool. So check here on Monday and I will post what these look like, okay? So I hope you guys have a really good weekend and you had fun with me doing some science experiments. I had a blast and I have learned a lot. So I hope you did too, and I look forward to talking to you on Monday.